Alrighty, today we're going to talk about titrations. So what is a titration? A titration is a neutralization reaction. And this is going to occur between an acid and a base. When these react, we always produce H2O, liquid, and whatever salt we have left over. And this is an ionic compound. So you're going to have your leftover metal and non-metal ions bonded together. So let's look at an example. I have a strong acid, HNO3, reacting with a strong base, magnesium hydroxide. When I go to write up my products, my cations are hydrogen and magnesium. They're going to undergo a double replacement reaction. And we're going to produce H2O because hydrogen is going to bond with hydroxide and produce water. And then my leftover is going to be my cation of magnesium bonded to nitrate. Now these charges don't add up to 0, so I need to crisscross. So my final equation is going to be MgNO3 2. Once I balance out this reaction, I'm going to see that I need 2 nitric acids and 2 waters. Everything else will get a coefficient of 1. In the lab, if I were to have a certain amount of my nitric acid, let's say I have a problem where I'm given 15.21 milliliters of HNO3 to react with 23.9 milliliters of a 2.1 molar magnesium hydroxide solution. And I want to know, well, what is the starting concentration of HNO3? Well, I can use this neutralization reaction that we wrote up above, the chemical reaction between magnesium hydroxide and nitric acid, along with a couple other tools that I'll show you, to figure out what is that starting concentration. So when you mix an acid and a base, they neutralize each other. So the pH comes out to be around 7-ish. So when I look at this problem, I'm going to highlight some important pieces of information. So I'm given the amount of nitric acid that reacted. I'm also given the amount of magnesium hydroxide that reacted. I'm given 2 pieces of information about my magnesium hydroxide. I'm given both the volume and molarity of my magnesium hydroxide, or of my base. I call this my known information. I'm missing a piece of information of my nitric acid. I'm only given the volume. I don't know the molarity, because that's what the question is asking. So there are 4 steps that we can perform to solve for the concentration of the acid. So our 4 steps are as follows. The first step, we need a balanced equation. Well, I have that up above. I'll just rewrite it down here. So I have 2 nitric acids reacting with 1 magnesium hydroxide. And that's going to make 2 water and 1 magnesium nitrate. And the reason why we need a balanced equation is that I need to look at the mole ratios. So this is really just a stoich problem that's broken down piece by piece. So the second step that we need to do, we need to solve for moles of your known solution. And in this case, it's the magnesium hydroxide, because when I solve for moles, I'm going to use the molarity equation, M equals moles over liters. Well, I'm given two of these pieces of information for magnesium hydroxide. So I'm given the concentration as 2.1 molar, and I'm going to solve for moles. My volume that I'm given is in milliliters, but I can convert my 23.9 milliliters into liters by moving the decimal spot 3 spots to the left. So I have 0.0239 liters. When I multiply both sides to get my number of moles by itself, cancels out on the right-hand side, I'm going to get, plug into my calculator, 0.0239 times 2.1. I get 0.05019. And you don't really want to round right now. You want to round at the very end because we still have a couple more steps we need to accomplish. So number of moles, 0.05019 moles of MgOH2. Okay. So that's how many moles of magnesium hydroxide reacted. Well, in order to solve for molarity of the acid, I need to know, well, how many moles of acid reacted? So my next step, I'm going to do a little bit of stoich to solve for moles of acid. So now I'm going to use my starting amount. I'm going to stoich to calculate moles of my unknown, which is my acid. So I'm going to take 0.05019 moles of MgOH2, and I'm going to set up a stoich problem. So in my next step, I'm going to have moles of magnesium hydroxide on the bottom. I'm going to have moles of nitric acid on the top. And I get this number from my balanced equation. So when I look at my balanced equation, for 2 moles of nitric acid, I will react 1 mole of magnesium hydroxide. And that's what's going to go in this step right here. So 2 moles of HNO3 for 1 mole of magnesium hydroxide. So when I multiply this by 2, I get 0.10038 moles of HNO3. Okay, great. So we're getting closer to our final answer. I don't want moles. I want to know what is the molarity. So the fourth step, you're going to use your molarity equation again, moles over liters, but this time we're going to solve for molarity. So the piece of information that we're given from earlier in this problem, so I was given that 15.21 milliliters of nitric acid reacted here. So now I got my volume, and I just solved for moles, so now I can use my molarity equation. So I'm going to set this up down here. I got 0.10038 moles of HNO3 over liters. So I'm going to convert my 15.21 milliliters into liters, moving the decimal spot 3 spots to the left. So if you need to see that 15.21 milliliters, you take your decimal 1, 2, 3 spots to the left to turn it into liters. So 0.01521 liters. When I divide these two numbers, divided by 0.01521, I will get 6.59960, blah, 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 blah. And this is going to give me my concentration. So we're finally going to round to 2 decimal spots. This is going to round me all the way up to 6.60 molar. And this is for your HNO3.